Hi, I'm Rowan, Product Manager at Q-CTRL. In this video, I'll be showing you how to get started with Fire Opal and run your first circuit within minutes. Fire Opal is an easy-to-use package that reduces error and unlocks the best possible performance from running algorithms on quantum hardware. By preventing errors from occurring at runtime, Fire Opal pushes device capabilities to near theoretical limits, enabling you to run 10 times deeper circuits. Because the methods that it uses are completely deterministic, you're able to get results within a single execution. This can save you over 100 times on compute costs compared to common error mitigation routines that require expensive sampling overhead. Additionally, algorithmic benchmarking has proven that Fire Opal can achieve over 1,000 times improvement over expertly configured error reduction methods. Best of all, it's super simple to use and requires no configuration or hardware knowledge. In this video, we'll go over the steps required to get started. This will include setting up your accounts, setting up your development environment, and running your first circuit. Let's get started. If you haven't already, you'll need to sign up for a Fire Opal account. You can do so by visiting the Q-CTRL website and then choosing the sign in option and clicking on Fire Opal. Here, you can go to the sign in option and fill out your information. Once you sign up for an account, look out for a verification email in your inbox. If you don't see it there, be sure to check your spam folder. For the purposes of this video, we'll be using an IBM Quantum computer. You can sign up for an IBM Quantum account online and start using some of their free devices. Depending on the hardware provider, you'll need to get account access information. For IBM, this is your authentication token, which you can find in your IBM dashboard. The next step is to set up your development environment. If you're already very familiar with Python environments, go ahead and skip to the next step. We recommend using a free tool called Anaconda to manage your Python environments and install packages. Now that I have Anaconda downloaded, I'll go ahead and create a new environment. This will be used to manage the packages that I want to use with Fire Opal, and I'll go ahead and name this Fire Env, and then I'll specify to pre-download Python. Now I'll go ahead and activate the environment. And then I'll be able to start installing packages that I'll be using in addition to Fire Opal for the purposes of this video. These include some Qiskit packages as well as matplotlib, which will be used to plot our results. Now that we've got our accounts and environments set up, let's go ahead and run our first circuit and we can see how much improvement Fire Opal yields. We'll go step by step through our Getting Started guide, which is also located on our docs website. The algorithm is a simple example of Bernstein-Vazirani, which is used to find a string from the outputs of a black box function. From our site, you can download this notebook directly to run it in your local editor. Now I've got the notebook open in VS Code, and we can start running through the steps. We've already got the setup covered, and we have already signed up for the proper accounts as well as installed the right packages. Means now we can jump into the demo. First, we have defined here a few helper functions. First of all, draw a circuit helps to picture and visualize our QASM circuit, and then plot BV results will be what we use to plot the results of our experiment. Go ahead and run this cell and just define those functions. Next, we can define and check the circuit using the draw circuit function. Fire Opal accepts circuits in OpenQASM format, and you can export to OpenQASM from most other frameworks and SDKs. By drawing the circuit using our helper function, I can make sure that the circuit is free from any possible errors. As a next step, we'll enter the device credentials information that we retrieved earlier upon sign-up. You can see this information in your IBM Quantum dashboard. You'll need to specify a hub, group, and project, as well as retrieve and specify your token. You can use the open and main group and project in order to access the open devices that are available to all users. It's important to know that Fire Opal only passes along your credentials information. It never stores, reads, or modifies any credentials. Now you can choose a device and choose to specify it as your desired backend. I'll be running on IBM Perth. Next, you can validate the circuit and the backend to make sure that they're compatible with one another. I'll go ahead and skip this step and just go ahead and execute the circuit. Executing the circuit may take a while depending on whether or not the device that you're using has a queue. You can check your place in the queue using the device provider's website, or even better, you can make a reservation on many devices in order to have dedicated device access. In the meantime, if you do have a wait, go ahead, grab a coffee, make some lunch, and come back to this later. Once you've gotten your coffee and your jobs have finished running, then you can now plot your results, and we'll use the other helper function that we set up originally. So I'll go ahead and run this. The results are plotted, and the results are pretty good. You can see that out of all of the shots that were executed, 82% of them were the correct answer. And so we get overall an 82% success probability. I've already also ran the same circuit using the default Qiskit settings, and so this was an execution that was without Fire Opal. I'll go ahead and plot the results here as well. As you can see, the results here were not as good. This was actually only 8.2% success, and as you can see, the correct answer wasn't even the one that came up the most. The results obtained using Fire Opal were more than 10 times better than the results that were achieved without. In fact, I'll go ahead and delete these cells in between so we can get a direct comparison. As you can see, the correct answer is much more discernible in the Fire Opal distribution than the distribution created without Fire Opal. And that's it. Now that you know how to get started with Fire Opal, you can go ahead and try running different algorithms using Fire Opal to optimize your hardware execution. Our documentation has a bunch of different tutorials and use case focused application notes, like solving the binary paint shop problem with Fire Opal's QAOA solver. If you have any questions along the way, join our Discord server to reach out to our team directly, or email us at support@qcontrol.com. We'll be happy to help out and make sure that you get useful results from your quantum computers.